This video is going to talk about the three types of nuclear decay. So we have alpha, beta, and gamma. These are their symbols. What you'll notice is the symbols are in what we call nuclear notation. I kind of mentioned this before, but anytime you see a symbol in this kind of format, you have the element, or sometimes it's not an element, right here, and you have a number in the top left corner and a number in the bottom left corner. So that top number is always going to be your mass number, and the bottom is always going to be your number of protons. An alpha particle is made up of 2 protons and 2 neutrons, which is why it has a mass of 4 and then a 2 on the bottom for the number of protons. This is why it's given the symbol He, because it's pretty much just the same as a helium nucleus. So when an alpha particle is being emitted by an atom, it's giving away 2 of its protons and 2 of its neutrons. So that means it's going to change something about the atom. Since it's giving away 2 protons, its atomic number is going to decrease by 2. And since it's giving away 2 protons and 2 neutrons, its whole mass number is going to decrease by 4. An alpha particle is relatively big compared to our other 2 kinds of decay, so it's actually very easy to stop. An alpha particle can be stopped by paper or skin. So something just really thin can stop an alpha particle. So they're not very harmful because they can't even get through your skin. So to show you a model of what this might look like, let's say we have this nucleus over here, this atom over here, before decay, that has 6 protons and 6 neutrons. So if it undergoes alpha decay, that means it's going to emit a particle made of 2 protons and 2 neutrons. So after decay, it should have emitted 2 protons and 2 neutrons. So that means the atom that's left after it's emitted, that particle should have this much less in its nucleus. So this is the atom that we would have left after it's undergone alpha decay. It would have 4 protons and 4 neutrons. So its total mass decreased by 4 and its atomic number decreased by 2. In a real nuclear equation, we're going to actually use elements and their real mass numbers and atomic numbers. If americium-241 undergoes alpha decay, that's our starting point, and then we need to figure out what comes after the fact. So we're going to have some new atom right here plus our alpha particle. And so our symbol for the alpha particle should be He4/2. Now we're going to have to fill in this blank with whatever our final element is, whatever our final atom looks like after it has undergone this decay. One easy way to look at this is to separate the numbers on the top and the numbers on the bottom and look at them as 2 separate, pretty simple math problems. Our arrow is going to represent an equal sign. Our plus sign is still going to be a plus sign. And then we have our top numbers and our bottom numbers separately. So on the top, we have 241 is equal to some number plus 4. So we could figure out that the number that goes in that blank is 237. On the bottom, we have 95 is equal to something plus 2. So on the bottom is going to have to be 93. Once we've figured out these numbers, it's really easy to figure out what element symbol is going to have to go right here, because remember that this bottom number is our number of protons. So if we know our number of protons, we can figure out our element. Number 93 on the periodic table has the symbol Np. So our answer to this equation would look like that. All of this should make sense because remember we said the mass number has to decrease by 4. It went from 241 to 237, and the atomic number has to decrease by 2. It went from 95 to 93.